Okay, let's look at a fraction that looks something like this, 4/8. Okay, there's a lot of times that it's helpful to break a number down into its factors. In other words, what are the numbers that multiply together to give you 4, and what are the numbers that multiply together to give you 8? Okay, and so let's do that here on the side. Let's take 4 and 8, and let's break them down into factors. This is called factoring, by the way. This is called a little factor tree. So I can say what times what equals 4, and it comes out 2 times 2. What times what equals 8? Well, how about 4 times 2? 4 times 2 is 8, and 4 will break down again to 2 times 2. So 4 ends up being equal to 2 times 2. I'm going to use dots for times. You can use X's if you like. When you get to algebra, you'll use dots. I'm just introducing it to you here. The 8 is 2 times 2 times 2. So these are the numbers here at the stems of this tree, so to speak. Okay. Now, what do we have when we have 2 divided by 2? Remember, this fraction bar is really a division bar. This says, what is 2 divided by 2? Well, 2 divided by 2 is simply 1. And 1 times anything is that anything without writing the 1 there at all. So I could just cross it out. So that's called canceling. If something is the same top and bottom of a fraction, I can cancel them out because it doesn't change the fraction to drop them out. It's just 1. 1 times something. Well, we can do that again right here. Here's a 2, top and bottom. And if I say 2 times 2, it looks like everything went away here, but not really, because 4 is 2 times 2 times 1. In other words, 1 is always a factor of everything. You don't have to write it down unless it's the only thing there, and then you probably want to have something there, so you can write 1. So look what's left, 1/2. Okay, so it turns out 4 over 8 is equal to 1/2. Let's look at a diagram of that. I'm going to put in some space here. If I have 4 of 8, so here's 1, 2, 3, 4, 5, 6, 7, 8. So let's make a bar 8 squares long. And let's look at 4 of those 8. So here's 1, 2, 3, 4. So here is 4/8. Okay. The fraction is eighths, so here's 1/8, 2/8, 3/8, 4/8. So here's 4 of the eighths, and that's the same as 1/2 of this length here. Okay, so 4/8 really is equal to 1/2. So this is the idea. If there's any factor in the top and bottom of a fraction, you can cancel it out and reduce the fraction. So it's a smaller fraction made with smaller numbers, usually easier to work with. Let's look at another example. How about 4/6? Well, you can either write them all out like I did before, or I can just look at it and I can say, I know there's a 2 in here. This is 2 times 2. And I know there's a 2 in here. That's a 2 times 3. So if I cancel out the 2, all I'll have left here is the other 2. If I cancel out the 2 here, what I'll have is the 3. So I could do it that way. If I wanted to, I could write it out. I could have said 4 is 2 times 2, 6 is 2 times 3, and one of the pairs of 2's cancel, leaving 2/3. So you can do it spreading everything out and then crossing stuff out, or some of these are easy enough you can just do in your head. By the way, you can do the reverse as well. If I start with 2/3, I'm free if I wanted to multiply top and bottom by anything. Let's multiply top and bottom by 5. So 5 times 2 is 10. 5 times 3 is 15. So 10/15 is the same fraction as 2/3. Let's prove that. Here's a calculator. And the way you find 2/3 is you take 2 divided by 3. So I take 2 divided by 3. Comes out 0.6666666, etc., all the way out. And that rounds up to 7 in the end, but it basically just keeps going. What if I took 10/15? Let's clear it. Take 10 divided by 15. 0.66666. Same number. So these become the same number when I divide them out on a calculator. Given the fact that I got this by multiplying top and bottom by 5, I think you can see I could go backwards and reduce it by canceling out the 5. So I could write 10 is 2 times 5, 15 is 3 times 5, and the 5's cancel, leaving 2/3. Okay? Of course, we knew that because that's where we got 10/15ths in the first place. Okay, that's the basic idea. You can take fractions that use big, messy numbers if they have common factors, if they have factors in common, if they have the same factor top and bottom, that number over itself is equal to 1, so it doesn't need to be there, and you can just throw it away. So in this case, 5 over 5, 5/5, that's just 1. So 1 times 2/3 is just 2/3. We just have 2/3. Okay? So there you have it.